Hello, and welcome to Shane's Microscope. I'm Shane, and this is my microscope. Let's take a peek. Today's sample comes to us from the papers all around my house. I decided to have a look at some of the common papers and see how they're similar, see how they're different. I figured we'd look at our samples wet, so that way we could get the best optical quality on those little tiny fibers and really be able to get a detailed look at them all. The word paper comes from the Latin papyrus, itself from the Greek papyros, which itself was probably an Egyptian loanword. And as you can see there, we are looking at some lined paper. Lined paper basically just needs to be cheap. That's its main manufacturing goal. You can see there a cut edge and some torn fibers. In all of these samples, I attempted to show us some torn fibers so we could really get some good detail. Up real close, we can see that the ink on this lined paper is not nearly so thick as it appears to the unaided eye. And that the cut edge is not nearly so smooth. It's almost like a little saw blade, so that's why paper cuts. And on the torn edge, we can get a good look at those fibers. So next I had a look at some printer paper, which in its basic form pretty much just needs to be white and hold ink well. You can see that the fibers on the printer paper definitely have a lot more on them, but otherwise look pretty similar to the lined paper. And up close we can see that as well, and it's likely that the particles that are stuck on those fibers are opaquing agents and sizing agents to give the paper the correct level of whiteness and opacity and glossiness, etc. This next piece of paper is off of a check. Checks basically need to hold ink well for identification and security purposes, and also so that trying to remove ink from them shows signs of tampering. And we can see that, like the printer paper, there's a lot of opaquing agents and sizing, and probably a lot of these are specialty inks, things that reflect UV radiation for security purposes and stuff like that. Now we're looking at a piece of facial tissue. This is usually used for clearing your nose, and you can see this is a much looser weave of fiber. Facial tissues basically just need to be soft, and having loose fibers allows them to be soft. And even in the bulk material, you can see a lot of light through it. Now, I thought this was very interesting. I think those are cell nuclei that we were able to see inside of those fibers, those little dots. You can tell that this is a more natural, less processed fiber than the previous papers we were looking at. And this here is a piece of toilet paper. It basically has the same requirements as the facial tissue. just needs to be soft, or at least it ought to be. I think some manufacturers have sort of forgotten that that's an important facet in toilet paper, but this kind is pretty soft, and you can tell that, like the facial tissue, it has a fairly loose weave. Definitely tighter than the facial tissue though. I guess the consequence is greater if something goes through this than the facial tissue. And again, we can see that these are less processed wood fibers. We can still see a lot of those cell nuclei inside of those strips of fiber. That's really neat. This here is a paper towel. Paper towels need to be really absorbent. They don't really need to be soft, but they should be free of anything that would scratch most surfaces. And we can see indeed that this paper towel has a lot in common with the facial tissue and the toilet paper. And just like those fibers, we can also see that there are some cell nuclei still in here. Or at least that's what I'm guessing we're looking at with those little dots. And our last sample for today is tracing paper. Tracing paper, as the name implies, needs to be transparent or at least translucent, and that can be done by adding oil or resin to the paper and then drying it. But that method kind of fell out of favor as soon as the Industrial Revolution produced machines powerful enough to compress fibers. The compression method is much more common now because if you add oil or resin to the paper, then that yellows and degrades over time. But in both cases, what you're really trying to do is get rid of the air gaps between fibers, which scatter the light. And so using a machine to press all the fibers together really hard accomplishes that same task without any additives. Or perhaps without nearly as much additives. We can see looking at these fibers that they've definitely added a little something to it. Well, I thought that was really neat, looking at the various kinds of fibers on the papers and being able to see what was going on with them up close. Alright, well, I think we'll leave it there for the day. Thanks for having a look with me. Until next time, keep on peeking.